L'Hôpital's rule, sometimes it's pronounced L'Hôpital, hospital. No, well, I mean, I guess not. So L'Hôpital's rule, we're just going to apply it, guys. We're not going to do a proof, an informal proof. It deals with limits, and don't worry, it's going to be really simple. Usually crowds go really fast through this. I don't think L'Hôpital's rule should be used all the time for indeterminate forms, but we'll see what's up. Okay, so let's find this limit here, x squared minus 4 over x minus 2 as x approaches 2. Can I do direct substitution? No. So what do we do in the past? Limit as x approaches 2, and then we took the difference of squares, x plus 2 times x minus 2, all over x minus 2, and then what cancels out? Yeah, bam, bam, cancels out. And then I just have that one factor, the x plus 2. So what is 2 plus 2? And there it is. That's my limit. Cool or not cool? All right, using L'Hôpital's rule. So L'Hôpital's rule states that if you get an indeterminate form, and there's only two that we're going to worry about, either 0 over 0 or infinity over infinity. And remember how positive or negative, it doesn't matter. And remember how I would tell you guys if it's 0 over 0, it most definitely has a limit. So here's what we do. If I plug in a 2, so I'm going to go ahead and I'm going to separate it first. Limit as x approaches 2 of x squared minus 4, and I get a 0. Limit as x approaches 2 of the denominator, x minus 2, and I get a 0. Try really hard not to do this, not to say 0 over 0, therefore I'm going to do L'Hôpital's. This is nothing. Like, this is not a thing. I mean, I guess it is a thing. 0 over 0 is indeterminate. But you might get penalized for it if you write equals 0 over 0, because 0 over 0 is indeterminate. It's not an answer. Does that make sense? Yeah, it's like saying 3 over 0. Can you do that? You can't divide by 0, so you would never write 3 over 0. You would just say undefined. That makes sense, guys? Okay. Because we get 0 over 0, because it's indeterminate, we can use L'Hôpital's. And L'Hôpital's rule states that I can do limit as x approaches 2, and I can take the derivative of the top. What's the derivative of x squared minus 4? 2x. And I can take the derivative of the bottom. What's the derivative of the bottom? 1. And that, as long as I don't get an indeterminate form again, that is my answer. So I'm going to plug 2. What is 2 times 2? And there it is. We got the same thing.
It's like game changing. Yeah.
Well, I don't necessarily think it's game changing, but
way more definitely nice.
Yeah. So when can I use L'Hôpital's rule? So I can use L'Hôpital's rule when I get this. And now remember, just don't equal it to that. Limit as x approaches c of f of x over g of x. If you plug in a c and you get 0 over 0 or infinity over infinity. Now, there's many other forms. There's also infinity minus infinity, but College Board doesn't focus on that one. There's also, 1 to the infinity or negative 1. There's all types of indeterminate. 0 to the 0. Okay, I'll stop talking. All right, here's the informal proof. We're not even going to talk about it. We're just going to look at it, but we're not going to do anything. So here's the informal proof. This is just a definition of a derivative as long as x approaches c. So notice f prime over c prime. So they just say limit as x approaches c is f prime over g prime as long as we have these conditions. And remember, you have to be differentiable, so the function must be continuous. Cool or not cool? Okay. Okay. All right, here we go, guys. So when do we use L'Hôpital's rule? Well, when we get complicated limits like this one. You know what? I don't know if we're ready. Oh, that's fine. We already started it. Before we tackle this one, let's do one more. This is not part of this. Limit as x approaches 0 of sine x over x. This one should be automatic. This is 1. You know it's 1, right? If we do L'Hôpital's rule, because we can, what's sine of 0? No. Sine of 0 is 0. And then look, if x is approaching 0, I get a 0 in the denominator as well. Do you guys see that? So doing L'Hôpital's rule, look at this. Limit as x approaches 0. What's the derivative of sine x? What's the derivative of x? 1. And now look, direct substitution, I get 1.
What? That's crazy.
See? Cool, right?
Yes.
All right, here we go. On this one here, there's not something you can factor out. On this one, you're forced to do L'Hopital's rule, like you have to. Well, first we got to check. Is it 0 over 0? So I guess I'm teaching pretty bad right now because I gotta see if it gets 0 over 0. So do you get 0 over 0? So I go limit as x approaches 0, and I just do the numerator, 7x minus sine x. And I can do direct substitution on that, and I get 0 minus 0, so that's 0. Now I do the denominator, limit as x approaches 0, of x squared plus sine 3x. And again, I get 0 plus sine of 0, which is again 0. So do you get 0 over 0? Yes, so I can do L'Hopital's. So here we go. I go limit as x approaches 0. What's the derivative of 7x? 7 minus what's the derivative of sine x? Just cosine x. Yeah. Yeah. Are we still okay? What's the derivative of x squared? 2x. What's the derivative of sine 3x? Cosine 3x times, so 3 cosine 3x. All right, here we go. I'm going to plug in a 0 now, and let's see what I get. If I plug in a 0 in the numerator, cosine of 0 is 1, 7 minus 1, over, let's see, 2 times 0 is 0, but cosine of 0 is 1 again, and 1 times 3 is 3, and 6 divided by 3? There you go. Yes?
So this is ways to find the derivative or the limit?
This is ways to find the limit, but only of indeterminate forms. If you get 0 over 0, you can do this, unless you see like you can factor or do algebraic manipulation. You know what I mean? Okay. All right. This is...
That's why you're teaching us this now, three-line limit.
Yeah, we couldn't learn this right off the bat because we didn't know how to do this. Here we go, guys. So we have this limit. The first thing I'm doing is I'm going to try direct substitution to see what happens. So I plug in a 3 in there, and I get, so I'm going to write limit as x approaches 3 of tan of x minus 3. And I notice that if I plug in a 3 in there, I get tan of 0, and tan of 0 is 0. Because tan is y divided by x. At 0 radian, the y is 0, the x is 1. And then limit as x approaches 3 for the denominator, 3e to the x minus 3 minus x equals, if I plug in a 3, 3 minus 3 is 0, e to the 0 is 1, 1 times 3 is 3, 3 minus 3, again I get 0. So I notice that I get 0 over 0. Is that indeterminate? It is, so I can do L'Hopital's rule. L'Hopital's rule states that I can just take the derivative of the numerator and take the derivative of the denominator. So what's the derivative of 10? So I write secant squared of x minus 3 times 1, but that's still itself. And now I take the derivative of the denominator. The denominator of 3e to the x minus 3 is itself. 3e to the x minus 3. And the derivative of x is just 1. All right, now I plug in a 3 and I see what I get. So 3 minus 3 is 0 in the numerator. And secant of 0 is 1, because secant's the derivative of cosine, right? Secant's the reciprocal of cosine, sorry. Cosine of 0 is 1, so secant of 0 is 1. So 1 squared is 1, so I have a 1 in the numerator. In the denominator, 3 minus 3 is 0, e to the 0 is 1, and 1 times 3 is 3, and then I subtract 1, and that is, so now I get my answer.
I like this.
Okay, cool or not cool? What is this called? L'Hopital's. Yeah, you can say hospital. Some people say hospital. L'Hopital's. Okay, this is from the 2018 AP exam, a more recent one. This is we can't do them all, but we can do most. I think only C we can't do. All right, so look. So this is no calculator. Question 5 is no calculator. Let's see what we can do. Let f be the function defined, and they give me a function. Find the average rate of change of f on the interval 0 to pi. Average rate of change. Do I have to do any calculus? No, you're just doing secant slope or slope. Average rate of change. So all I'm doing is f of pi minus f of 0 over pi minus 0. y2 minus y1 over x2 minus x1. Are we okay?
Wait, why are you saying f of pi? Oh, wait.
It says average rate of change, so I'm doing y2 minus y1 over x2 minus x1. All right, here we go. On the side, I'm going to go f of pi, and I'm going to see what f of pi is. E to the pi cosine pi. So e to the pi, that's some number. Do not plug anything in for this. And then cosine of pi is -1. So that's just negative e to the pi. Don't even try putting decimals in this. F of 0, your test will get flagged because you don't have a calculator. How would you know? F of, well, I guess maybe there might be some people that might know that. E to the 0 cosine of 0. E to the 0 is 1, and cosine of 0 is 1, so this is just 1. Yay or nay? All right, so here we go. I'm going to put equals. I'm going to put negative e to the pi minus 1 over pi. That is full credit. Leave it alone. That is full credit, but I don't recommend it. I just recommend what's in red there. Cool or not cool? Okay, yeah, be brave, guys, be brave. What is the slope of the line tangent to the graph of f at x equals 3 pi over 2? What do I need for a tangent line? Point and slope. Do I have a point? Well, yeah, we're going to get our point, and I'm going to find my slope in a little bit. So here we go. Let's find our point. Plug in a 3 pi over 2. So f of 3 pi over 2 equals e to the 3 pi over 2. We don't know what that is. Leave it alone. Cosine of 3 pi over 2. Cosine of 3 pi over 2 is 0, and 0 times anything is always 0. So my point is 3 pi over 2, comma 0. Are we okay? Next, I need to take a derivative. What rule do I use for the derivative? I'm going to rewrite it again. E to the x, cosine x. What rule do I use for the derivative, guys? Product rule. I'm going to underline and not double underline. So f prime of x equals first derivative of the second. What's the derivative of cosine x? Negative sine x. Use parentheses, guys, because sometimes, look what would happen if I take out the parentheses. Doesn't it look like you're subtracting? So be very careful. I know some of you put a little dot there, and I guess maybe that might fly. But the best choice is just to use parentheses so there's no confusion. It's a product rule, and it's negative sine x. Cool or not cool? Okay, first under the second, plus or minus? Plus second cosine x. If you want to use parentheses, that's cool. Times root of the first. Perfect. That's probably a point. I'll look at the rubric in a little bit. Now what am I going to plug in to get my slope? 3 pi over 2. So let's see, e to the 3 pi over 2. Negative sine of 3 pi over 2. Well, sine of 3 pi over 2 is negative 1. Negative 1 times a negative? Positive. So positive 1. Plus cosine of 3 pi over 2, which is 0. E to the 3 pi over 2. So 0 times anything is 0. So my slope is e to the 3 pi over 2. I'm ready for the tangent line. So, yeah, we haven't gotten a tangent yet. I'm going to write it right here on the side, guys. Y minus 0, so you don't have to put that, equals slope, e to the 3 pi over 2, parenthesis, x minus 3 pi over 2. If you want to distribute, it's up to you. I would not. I would leave it right there. How do we feel? Nothing crazy? Okay. Bless you squared, bless you cubed, bless you to the 4th power. Oh yeah. Yeah, you got me. Find the absolute minimum value of f on the interval 0 to 2 pi. Okay, we don't know this yet because we don't know critical numbers. So I'm going to put not yet. Maybe after Turkey Week we'll talk about critical numbers, max, mins. We don't know about maximum yet, so not yet. Letter D. Let g be a differentiable function such that g of pi over 2 equals 0. The graph of g prime, the derivative of g, is shown below. Find the value as a limit as x approaches pi over 2 of fx over g of x, or state that it does not exist. Justify your answer. They noticed that it was, well, I guess let's talk about it. F of pi over 2. So on the side, I'm going to write f of pi over 2. And did we already do f of pi over 2 in the previous, or no? No? No. Okay. E to the pi over 2 cosine pi over 2. Cosine of pi over 2 is 0, so anything times 0 is 0. And then g of pi over 2, they told you that is 0. See right here? So if I were to do direct substitution, you get 0 over 0, correct? And as soon as kids, because a lot of kids, we had never had one of these questions before, a lot of kids did that, and already that took them out. They took them out of all the points, but they could still get some points. So it took them out of a point right there for sure. The next move that you had to do, you had to state this. You had to go limit as x approaches pi over 2 of f of x. That equals 0, and then that's a separate limit. And then here we go. Here's my denominator. Limit as x approaches pi over 2 of g of x equals 0. And then I think you had to make a statement, and the statement said something like, because f and g are differentiable, comma, differentiable, and well, if you're differentiable, you're continuous. F and G are continuous, and since limit as x approaches pi over 2 of f of x over g of x is of undeterminate form, comma, we may use L'Hopital's. They have to state something like that to get the full credit. And you'll see right now. We'll look at the rubric in a little bit. I'm pretty sure I put it in here. I just haven't looked at it because I don't want to be biased. Yeah. Bless you, bless you. All right. You guys ready? Here we go. Limit. Oh, now I'm answering the question. Limit as x approaches pi over 2 of f prime of x over g prime of x. I'm doing L'Hopital's equals, well, I already have the derivative for f prime. So it is right here. I'm going to plug in pi over 2 into that. So, because I think we're going to get an answer. So, or if you get 0 over 0 again, I'm doing it on the side. E to the pi over 2 cosine, did I get a cosine or was it sign? No, negative sign. Okay, so negative sign of pi over 2 is negative 1. So I'm just going to put negative 1. Plus, and I think that one's a 0, 1, right? Cosine of pi over 2 is 0 times e of pi over 2 over, and then here's my derivative. Look, this is the graph. This is my derivative graph right here. It says g prime. At pi over 2, what is that derivative? What is the value? 2 over 2. So let's see. That goes away. Negative e to the pi over 2 over 2 is your limit. How do we feel? Yeah. No. Look. Yeah, we're going to look at the rubric right now. Go to the next page. I put the rubric there. Huh? No, I did it. Well, this is brand new notes. I revamped it. All right. The average rate of change of f on the interval 0 to pi. Okay, by the way, I guess we've done a few free responses, but let me tell you the gist of all free responses. All free responses, all of them are worth 9 points. So let me give you a goal. I want you to be more ambitious, though. If you want a 3, remember a 3 is like half of the test correct, right? So if you want a 3, in order to get a 3, you need to be getting about 4 to 5 points. If you want a 4, you need to be getting like 6 points, maybe 7. Actually, 7 might actually be pushing you towards a 5. If you want a 5, you got to aim for 7 points and more. Cool or not cool? There's 6 FRQs. But look how many points we can get right now in just this one FRQ. How many points for letter A? 1, and it's just this. If you have that, you get your 1 point. Did we get it? Look at letter B. How many points? Now notice that you get a point for just stating the f prime. So this is why I tell you guys. So look, if you got this derivative, all you have to do is use product rule. If you did the product rule and you got the correct derivative, even if you messed up with the slope, like getting the value, like oh, I don't know, pre-cal, I think it's blah, 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 and you messed up with the slope, they'll give you a point for the correct derivative. Isn't that cool?
Is that what you did with points when we start stuff?
And then, yeah, that's why I give you guys points. So that's why I'm telling you, don't try. I mean, I know some of you are smart, and I know you can do a lot of it in your head. Try to put your ideas that you have in your head on paper so you can see if you qualify for some of those points. Then they give you 1 point for the slope. Did we get e to the 3 power over 2? There it is. We got both of those. We're not ready for letter C. Letter C takes up 3 points, so don't even look at that yet. Look at letter D. I want you to notice 3 points, but look at the note. Max 1 of 3 if no limit notation attached to a ratio of derivatives. So they give you 1 point if no ratio. If you didn't write the limit, if you didn't write the word limit. Notice they wrote limit as x approaches power over 2 of f of x, and they wrote limit as x approaches power over 2 for g of x separately. So they don't want you to write it together and write 0 over 0 because that's not a thing. Yeah, and then notice it says by L'Hopital's rule, 1 point for stating g is continuous at x equals power over 2. Okay, I didn't state it directly, but I stated that indirectly by saying right here. G are differentiable, f and g are continuous. I think right there I would have gotten my point because I'm just saying that they're just continuous. Maybe we should be more specific and say continuous for all real numbers or for the entire domain. So there's my point right there on that. And limits equal 0. I got my point by doing the ratio of the top and the bottom. And then applies L'Hopital's rule. Here's my application of L'Hopital's rule right there. And then the answer. 1 point for the answer. Did we get that as an answer? Yeah. So look how many points we would have gotten. 3, 4, 5, 6 points. You're at a 4, maybe even borderline 5. Cool, right? Okay. Let's do a few more questions. And then we'll do practice. And then we'll call it a day, guys.
That's crazy.
All right, so look at this one. The graph of a function f is shown below. Determine the value in simplified. So before you do anything, see if there's an actual value for this. Limit as x approaches negative 2 of 4x squared plus 8x. Let's see what this is. So negative 2 squared is 4. 4 times 4 is 16. And then 8 times negative 2 is negative 16, so I get a 0. That's the numerator. Limit as x approaches negative 2 of 3f of 3x minus 3 equals, let's see, 3f of negative 6 minus 3, which equals f of negative 6. This is the graph of f. F of negative 6 is 1, so I get 3 minus 3, which is 0 again. Can I use L'Hopital's rule? Yes. Here we go. Limit as x approaches negative 2. So I'm taking the derivative of the numerator. What's the derivative of 4x squared? 8x plus, what's the derivative of 8x? 8 all over. And the bottom, the derivative, you got to use chain rule. 3f prime of 3x times 3. So what's 3 times 3? 9f prime of 3x. And there it is. So now let's plug in a negative 2. I'm assuming I'm not going to get another 0 over 0, but yeah, you won't. So 8 times negative 2 is negative 16. And negative 16 plus 8 is negative 8. And then the bottom, 9 times f prime of negative 6. So I need my slope of this line right here. It's 1. So 9 times 1. So my limit is negative 8 over 9. How do we feel? Okay. Last question. Are you guys happy that we're learning all this cool stuff? What is this called? L'Hopital's. All right, here we go. Give selected values of the function f and its derivative in the table. Determine the value. Okay, so here we go. Limit as x approaches. I see a 2, and I'm going to write the numerator. 2x squared minus 8 equals 2 times 2 squared minus 8. 2 squared is 4. 4 times 2 is 8. 8 minus 8 is 0. Limit as x approaches 2 of 2 times f of 2x plus x. Let's see, 2f of 4 plus 2. So let's see, 2f of 4 is negative 1. Sorry, I took attendance. Mr. Chavez. Yes, ma'am. Yes. Okay, so not yet though. Give me. You're going to Arzamendi's office, but let me do this really fast. All right, here we go. Negative 2 plus 2 is 0. Oh, I already did that. Okay, do we get 0 over 0? Yes. So can I use L'Hopital's rule? Yes. Here we go. Limit as x approaches 2. And I'm taking the derivative of the numerator, 2x squared, so it's going to be, what, 4x? Over 2f prime of 2x times 2, so it's going to be 4f prime of 2x.
Plus 1.
Plus 1. Thank you, guys. I was about to get that one wrong. Okay, here we go. I'm going to plug in the value 2. 4 times 2 is 8. And then f prime of 4, because I'm plugging in a 2, so f prime of 4 is, so 4 times negative 2 plus 1. So my final answer, 8 over negative 8 plus 1, negative 7. So negative 8 sevenths. I guess we don't have to redo it like that. And there it is. How do we feel? All right, so you're going to be happy, guys, because I put, they only have one subtopic on Delta Math, 7 questions, correct? But I lowered the penalty from a point to a half a point. So that's to your advantage. So I'm not going to always do it, but I'll do it for this one. So, so go ahead and take care of business, and we're done, guys.
Oh.